Good morning and welcome back, students. We will continue our topic of enzymes, and today's competency is competency number 2.3. In this competency, today we are discussing about enzyme kinetics. So in this enzyme kinetics, first we have to see what is meant by velocity of reaction. Velocity of reaction is nothing but it is the rate of conversion of substrate into product. Every reaction has its own velocity and it attains a maximum velocity when all enzyme molecules involved in the catalysis. So each reaction has different maximum velocity or Vmax, which depends on the concentration of enzyme and the concentration of substrate. So Vmax is very specific for enzyme and substrate. That means it is very specific for a reaction. This graph shows that Vmax is achieved when all enzyme molecules binds with the substrate and catalysis occurs at a particular time. So Vmax is achieved when all active sites of enzymes are occupied by the substrate. Next, come to equilibrium constant of a reaction. Suppose a reaction in which substrate A plus B is converted into product C plus D. In this reaction, K1 is the rate constant for forward reaction, whereas K2 is the rate constant for backward reaction. At equilibrium, all of us know that rate of forward reaction is equal to rate of backward reaction. So equilibrium constant is given as a ratio of rate of forward reaction to the rate of backward reaction, that is K1 by K2. Now we will see about one more constant, that is Michaelis-Menten constant, denoted by Km. All of you know that according to Michaelis-Menten theory, enzyme combines with substrate to form a temporary enzyme substrate complex or ES complex. It is a reversible reaction, and then this ES complex is broken down into enzyme and product, which is irreversible reaction. So the rate of formation of ES complex is equal to its rate of breakdown. That means either the enzyme substrate complex is broken down into enzyme and product, or it may broken back reversibly into enzyme and substrate. Suppose 100 molecules of ES complexes are formed in 1 minute, and out of that, if 25 molecules of ES complexes are broken down into enzyme and product, then the remaining 75 ES complexes are broken down back into enzyme and substrate. That means the formation of ES complex is equal to its breakdown. Now suppose K1 is the rate constant for the formation of ES complex, K3 is the rate constant for the breakdown of ES complex into enzyme and product, and K2 is the rate constant for breakdown of ES complex into enzyme and substrate. Now in this situation, formation of ES complex, that is K1, is equal to its breakdown, that is K2 plus K3. Therefore reaction is K1 is equal to K2 plus K3. Now the Michaelis constant Km is again a ratio of dissociation of ES complex to the formation of ES complex, and it is given by K2 plus K3 divided by K1. Now velocity of the reaction. Velocity of the reaction at any time is given by the formula Vmax of that reaction, or maximum velocity attained in ideal condition by that reaction, into the substrate concentration divided by Km or Michaelis constant plus substrate concentration. So this is the formula for calculating the velocity of the reaction at any time. But if we apply a condition in which we have kept the substrate concentration is equal to Km. Km is nothing but substrate concentration. So when we take a substrate concentration equal to Km, then in that situation we will substitute the value of Km by substrate concentration. So the formula of velocity becomes Vmax into substrate concentration divided by substrate plus substrate concentration. Here we have replaced Km by substrate concentration. So this becomes Vmax into substrate concentration divided by 2 into substrate concentration. If we cancel the substrate concentration from numerator and denominator, then we will get Vmax by 2. That means half Vmax. So velocity of the reaction we have getting as half of the maximum velocity. And when it is possible? When we have applied a condition which is substrate concentration is equal to Km. That means when the substrate concentration is equal to Km, then at that point the velocity of the reaction is half of the maximum velocity achieved by that reaction. So this is Michaelis-Menten constant or Km. Km is defined as it is a substrate concentration at which velocity of the reaction is half of the maximum velocity, which we have seen in the previous slide. So this is the graph here, velocity versus substrate concentration, in which the Vmax is seen at the top and a point is chosen between 0 and Vmax on y-axis. That point gives us the half of the maximum velocity. Now draw a perpendicular from that point on the graph, and from that point on the graph draw one more perpendicular on x-axis. Then that point corresponds to the value of Km. So from the graph also we can define Km. Km is nothing but it is a substrate concentration at which velocity of the reaction is half of the maximum velocity of that reaction. And when Km is achieved at the point when half of the active sites of the enzymes are occupied by the substrate and half of the active sites are free. Now the next is Km is independent of enzyme concentration. So in this graph I have taken same enzymes in different concentration. In the first situation I have taken enzyme E1 as 1 unit. At that time I have got a maximum velocity of the reaction which I have denoted by Vmax1. Then the same enzyme I have increased its concentration by 2 units. Then at that time I have found that velocity of the reaction is increased, and from the graph I have given the name of that maximum velocity as Vmax2. So I have found that Vmax2 is greater than Vmax1, and it is simply because I have taken enzyme concentration more. More enzyme concentration means maximum velocity is also more. Then I have chosen a point between 0 and Vmax1, and that point indicates half Vmax1. Then I have choose a point between 0 and Vmax2. That point indicates half Vmax2. And from this point I have plotted a perpendicular on respective graphs. And from these points on the graph I have dropped a perpendicular line on x-axis. Then I have found that the perpendicular lines from the two different graphs I have plotted on x-axis will meet at the same point, and that point is nothing but Km. What is Km? It is a substrate concentration at which velocity of the reaction is half. So though I have taken the enzyme concentration differently, I have got same Km for that particular enzyme. By changing the enzyme concentration, there is no change in Km. So I can say that Km is independent of enzyme concentration. Next, Km is the signature of the enzyme. Km is called as signature of enzyme. Why it is called so? Because every enzyme has its own Km for a particular substrate. If suppose if you are given an unknown enzyme and if you are asked to identify the enzyme, then calculate the Km for that enzyme, and when we get the Km value of a unknown enzyme, from that Km value you can find out the particular enzyme. Therefore it is called as signature. Just like a bank persons will identify their customer by their signature. Similarly, by identifying the Km you can identify the enzyme. Hence it is called as signature of the enzyme. Now another point is Km denotes affinity between enzyme and substrate. That means if the affinity between enzyme and substrate is high, Km is low. It is inversely proportional to affinity between enzyme and substrate. And it is practically seen that when the affinity between enzyme and substrate is high, then they readily combine in the medium. At low substrate concentration, they will combine and half of the active sites of the enzyme are easily occupied by the substrate at low substrate concentration. Why? Because their affinity is high. So when affinity is high, then to get half of the maximum velocity, we require less substrate concentration. Less substrate concentration means the Km is low. Similarly, when the affinity between enzyme and substrate is low, therefore they does not combine readily into the medium. At that time we have to increase the substrate concentration to get half of the maximum velocity of the reaction, and when the substrate concentration increases, Km increases. So Km is inversely proportional to the affinity between enzyme and substrate. Next is dissociation constant. Dissociation constant is inversely proportional to Km. What Km indicates? Km indicates affinity. When the affinity between enzyme and substrate is more, its dissociation is less, and when affinity is less, dissociation is more. So this is Kd is inversely proportional to Km. This graph already we have studied in the beginning. When no enzyme combines with substrate, velocity is 0, but when all enzyme molecules combines with the substrate, the velocity of the reaction is more or maximum, which is called as Vmax. Now maximum velocity of the reaction is very difficult practically to achieve for a particular reaction. Maximum velocity is achieved in two situations only. The first situation is the substrate concentration should be very, very high, and the other condition is the affinity between enzyme and substrate should be high, very high. At that time only all enzyme molecules combines with the substrate and we will get a maximum velocity. So practically it is very difficult to achieve Vmax for all enzyme reactions. If Vmax is not achieved, then we cannot find out half Vmax, and if we cannot find out half Vmax, then it is very difficult to find out Km. Now this practical difficulty of calculating Km is overcome by this graph called as Lineweaver-Burk plot. Now in this graph, what we have taken, on x-axis we have taken reciprocal of substrate concentration. In the normal graph we have taken substrate concentration on x-axis and velocity on y-axis, but in this situation on x-axis we have taken 1 by s, that is reciprocal of substrate concentration, and on y-axis we have taken 1 by v, that is reciprocal of velocity. So in both x-axis and y-axis we have taken reciprocals. Therefore it is also called as double reciprocal plot. Now after taking these points on x-axis and y-axis, we will take the particular substrate concentration and then we will plot the points. After plotting the points, we will join these points with the line. Then we will extend this line behind on the negative side of the x-axis to cut the x-axis on negative side also. We have extended, we have not got this point, we have extended the straight line on the negative side of the x-axis. Now the point at which the line cuts the y-axis, at that point, this point indicates reciprocal of maximum velocity, that is 1 by Vmax, and the line where it cuts the negative side of y-axis, means it is on the left side of the 0. So that point indicates negative of 1 by Km or negative of reciprocal of 1 by Km. So once we get the negative value of 1 by Km, then by mathematical calculation we will easily calculate the value of Km. Once we calculate the value of Km, then we can identify the enzyme, or we can find out how much substrate is required for a particular reaction to achieve the maximum velocity. So in this way, with the help of Lineweaver-Burke plot or double reciprocal plot, we have find out the Michaelis-Menten constant. Here it is written that x-axis is minus Km, just we have seen in the graph, from which we can easily calculate the value of Km. Now this is about enzyme kinetics. Thank you very much.